What's up, YouTube? Welcome back to this series on writing a interpreter for a small programming language. So the last time we wrote code that took a string like this, or like this, and turned it into an abstract syntax tree. And right now the only thing we can do with it is to print it. So if we run this test, there's a lot of warnings still, but the test passes, and that means that we was able to take this abstract syntax tree and format it in some way, in particular in this way, kind of a Lisp-like notation where you can easily see the tree-like structure. So that's it for this chapter. Now we go to the next one, and as always I think I will read this and then we will return. Okay, so what we are doing now is redefining the grammar, and basically the problem is that we have this ambiguity problem where a string like this could basically be generated by in two different ways, leading to two different abstract syntax trees. Basically it could be interpreted either as this or this, and clearly we don't want to have like an ambiguous grammar, so we need a solution to that. And the way it's solved, and I'm not entirely sure exactly how yet, but I guess it will make more sense once we write the parser, is to make the grammar a little bit more complex. So before we had, I wonder if we can see it here, not easily, but maybe here. But basically we add extra terms in our grammar, and they are written in order of increasing precedence. So basically means that the primary expression is evaluated before the unary, which is evaluated before the factor, and so on. And when we write the parser to match on this, then again, not sure how, but then automatically the precedence problem will be solved. And so I just want to go through it. So we have an expression which is just the same as an equality. It's basically there for readability. Then we have the equality, which is can be a comparison, which means that if you have an equality between two things, then that is the last thing you evaluate. And the thing that you evaluate before that is a comparison. So comparison can either be just a simple term. So remember that these stars mean 0 or 1. So an equality can also just be a comparison. A comparison can also just be a term can just be a factor. So they can all sort of like bottom out down to the primary one. But basically this means that you should evaluate the things on the either side of the equality before you evaluate the equality. And then you have the comparison, and you need to evaluate the things on either side of the comparison before you evaluate the comparison. Makes a lot of sense. Then there is a term which is just plus or minus, and before that you have to evaluate a factor, and a factor is a multiplication or division. And before that you have to evaluate a unary thing, which is just negation, or logical negation or numerical negation. Or it's a primary thing. A primary thing is just a value, or it's a parenthesized expression. So you can kind of like get nested things. So I hope that made a little bit of sense, but I think it will make even more sense once we actually write the parser. yeah, so basically what he writes here is we're going to do a recursive descent parser, which means that it's a top-down parser, so we start from the top and match on that, I guess. And that's how you will get the same precedence structure that you have written here. So let's get started and write a parser file. And we're going to use the token type. So let's do this. And we need some kind of class. Make it public too. And it should have a list of tokens. And we also need then to import token. And a current. It's an integer here, but probably it can be unsigned. And there's no errors, right? Yes. There's a new function. Okay, let's also make that. Good. Like the scanner, the parser consumes a flat input sequence, only now we're reading tokens instead of characters. So we run the scanner on a string, gives us some tokens, then we put it into this, and that should generate an abstract syntax tree that we know how to print, and later on we will also evaluate it. So we use current to point to the next token eagerly waiting to be passed. We're going to run straight through the expression grammar now and translate each rule to Java code. Or Rust code, as the case may be. The first rule, expression, simply expands to the equality rule. So that's straightforward. Okay. So the idea is that he also writes here that each thing in the grammar will correspond to a function. And so expression will evaluate to equality, and then equality will evaluate to something a little bit more complex, because it can either be a comparison or it can be a comparison with other things. So some rules here, but we'll see how it works. So let's, it's a private function for whatever reason, so, but okay, I'm fine with that. So I guess we will eventually need a mutable reference to self, and we don't want to return anything, I think. So let's just do this. Then we need the equality, and each method for passing a grammar rule produces a syntax tree for that rule and returns it to the caller. Right, so I guess we also need to use the expression stuff. And we want to return an expression, and we'll put to do here and just quickly check it. And it looks fine. I really have to get rid of those warnings. And returns it to the caller when the body of the rule contains a non-terminal, a reference to another rule, we call that other rules method. Yeah, sure. So the rule for equality is a little bit more complex. So here we have it. So it can either be something, or it can be something with a comparison, with an equality, and something else, and that sub-expression can be any number of times. So we should first get the left-hand side, and then we will call the comparison function, and this will consume some tokens and move the counter up So that's why we need a mutable. And then we want to say there's some match function, which we haven't defined yet. But very interesting. So basically, this one should look at the next token and see if it's one of these. And if it is, then we know we are in this case. So first we will consume this, which can be any number of tokens. So we call this comparison function. Then we match on this, and if there's a match, then we do some things, but basically we consume this. But then because of the star, there could be another equality. So we go back and see, do we have another equality? If we do, then we need to get another comparison thing. So let's see how it works. So the operator will be the previous. The right-hand side will be another comparison that we just eat. And then, okay, interesting. So let's actually call it expression. Then we will create a new expression, which will be, let me see exactly how we defined it here. It will be a binary where the left is expression, the operator is operator, and the right is the right-hand side. And once we have that, we just return it. Let's format it. Okay, so we cannot do this. We have to say match token. Interestingly, this doesn't work. Now it works. Okay, so we haven't written these functions yet, but we just assume they work. So I hope it makes sense. So we read a comparison expression. We see if we can match one of these guys, and then this will evidently advance the current pointer. So we need to look one back at this point to get the actual operator, and then when we have the operator, we just read the next comparison expression, and then we feed it into this thing. So let's step through it. Okay, that's what I just did. First comparison non-term translate. Yes. Yes. Okay. So here we actually only need now this is interesting. I don't know if we have, so here is like a variadic thing. I don't know if we have that in Rust, so let me check. Okay, as far as I can see, there's not a good way to do it. We can make a variadic interface, you could say, with a macro, but it doesn't really allow us to easily return return early. So we can just evaluate a bunch of things and then return a value, but that's not really what we want. Or it would work, but it's not so nice. Or maybe it is. I'm a little bit torn. Let's do it. We'll make a match tokens macro. And it will take some tokens. Now I have to remember how you do this, which will be identifiers, sure. And there should be at least one. And I think you need a comma here for reasons. And we want to call we want to say something like this, and then we want to say, isn't it like this? Forget how it works. So we need to say self dot check, why not? And then we want tokens. So we can also just make it a little bit more nice to read down here. So we check if the thing that the current pointer is pointing to is equal to this token, and then we say result is equal to this, and finally the return value of this thing is the do we really need to wrap it like this? I don't know, I guess. Then the value of this block is the result. Maybe it's not a big deal that you here, so here you have to check every single thing. I guess. Maybe it does short circuiting like this, I am not sure. Anyway. So we will say match tokens on these things, and it should call self.match token. I don't know if this call to self will work, but we'll see. So what we want to do is something like this, check. It also has an isEnd, okay. isEnd, return false, else. And it needs a type as well. We cannot say type, yes. So, and the type should be token type. All right. And we cannot have this. So, do this, which I think is what it should be. Let's look in the scanner in the token class. Or enum struct, whatever. Here it is, token, so it has a token type, token underscore type. Great. And okay, so we are really getting a lot of functions here. And I'm not, so he also has this advanced thing, but I'm not going to include that right now. I mean, I'm sure we will need it, so I will write the function, just won't, and it should return a token. So, if not, and he really likes this previous. How about just token self.peak and token. Okay, that would be a bug actually, so maybe we do want this previous. Okay. We want to peak. Just return the current one. We want the previous. So here is where this previous might get a little bit annoying, because we have to say -1, which you cannot necessarily do with usize. So maybe we have to go back and change that. And if we want to check if we're at the end, where we simply return if the one we're looking at is end of file. Okay. We will then make a stop for this comparison thing, so that we can try to compile it. It did compile, right? Yes. Probably because this is not included, so we need to actually add it, so it tries to compile it. Check it. Yeah, there we go. So, cannot find macro rules. Match tokens. Okay. Now this is interesting. So I'm just basing it off this thing. I'd really want this anyway. Surely it's not this. Very strange expected expression. I would say this is an expression, but okay, what happens if I do this? No. So let's also add like an identifier to the parser. And then can I do self? So I want to include also expression, all of the variants, and expression, and token type. Okay. Still some errors. Expression. Okay. Let's I was also complaining about the compare comparison thing because I didn't spell it right. And this has to be a box. Now let's go back here and say, try to figure out what is complaining about. So let's check the Rust Lang book. Macros. So why does this one have a comma and the other one doesn't? Maybe it's because it's calling another macro, so let's just remove it. Now it doesn't complain. Cannot move index out of index of vector token. Huh. So I think I'm just gonna excuse me. I think I'm just gonna implement copy, see what happens. Copy may not implement it, so right. We need to implement copy for. Wait, why did it complain? Trade copy may not be implemented for this type. This field does not implement copy. Huh. Fair enough. Then I just clone it. I have to clone this one as well. Not super nice. You know what? We don't need this. We don't need to have a token we own. We just need to look at one. So this is actually more correct. At least it's more memory. Cheap. So now we have the problem that this one actually does want a token. Again, it doesn't really need it, right? Maybe we go into expression and change it to a reference. The same here. Now we'll get errors in here, but that's fine. Then we need a lifetime. I will just add this. Huh. How does that work? Looks really weird, but if the compiler says I should do it, downside is now we need all these lifetimes, but whatever. Now we go back to the parser. 72. Interesting. So has to be mutable. Huh. Okay. And we do need this advanced thing now. Let me see. Otherwise we'll get a bug. And then we have to say if we match, then we advance, and we return the previous, we return true. Then we can implement match tokens, where now it will just take a, maybe we can do like this. Okay, let's see if we can get that to work. We have something on line 59. All right, so there we go. We have something here on line 70. What's it complaining about? Expected enum token type found a reference to token type. Okay, whatever. A little bit confused because cannot borrow self is mutable more than once at a time. Is it because this borrow lives for the duration of this thing? So let's say let matches. Let's try this. No, it doesn't like that either, so. So we really need everything to be mutable. That is slightly weird, but okay. Huh. So it seems like now that we no, it shouldn't be that. I'll try something. No, still. What if we don't make it mutable? What will happen then? Oh my god. Let's look at the one of the others just. Are they all the same? It's just complaining about different parts of this. So we have a fundamental problem here. Which can be solved in this way. It turned out that the lifetime we added here on the expression enum was kind of the source of the problem. And it's a little bit sad that we couldn't do it. Probably it means there's something wrong with the way I thought about it, but now if we just clone the tokens here instead of holding references, then there's no problem. But it does mean we like copy extra data that we really shouldn't have to copy. So I don't know how to think about that. Let's on the one hand side I want to do it the right way, on the other hand side I want to get something working. So just because it's already been a long video, let's just try to get it working. So we have implemented all of this stuff and we just need comparison. So term while self.match tokens say there, we return the expression. Now let's write the term. They are very similar. So actually, I'm going to just write these functions off screen. All right, I think I finally wrote most of it. A lot of the functions are just very similar to what we've seen already. The primary function, it looks at a, let's move this down here actually. First it sees if it gets left parentheses. If it does, it takes an expression, then it expects a right paren, and then it just returns the grouping expression. And otherwise it looks at the token, and we should also advance. It looks at the token, advances one step, and then it returns a literal value. So I also created this literal value from token helper function, which simply looks at the token type and then creates the corresponding literal value in the expression tree. So there's some kind of bad redundancy here, which we should fix. You see, we also have a literal value enum here, which mirrors it somewhat, so maybe it's okay. But basically it looks at the token type and sees, okay, if it's a number, then we try to unwrap the literal. Also not that nice that it needs to unwrap, but whatever. Yeah, it's basically just type conversion. So the only thing we actually need is this consume function, which I guess will be something like this. Then we advance, otherwise we panic with this message. And it doesn't like that. It has to be a string literal. I have to do this for whatever reason. Now there's no weird. Let me look in the scanner. We do have nil. So I'm actually think I'll have to add token type. Okay. So I think that's it for this video. We haven't really run any code, which is never good. You should test it. But I think we basically have a fully working parser of these simple mathematical expressions. So we will definitely test that next time.